A 3D diagram again. Remember that in part A, usually the 4 marks is can be easily attained by just using sine formula, cosine formula. The key point is whether you can identify the useful 2D shape. So we just label all the items that we need. We know that angle BAD, that means this angle is 86 degree. And then angle CBD, this is 43 degree. And then AB is equal to 10, AC equal to 6, BC equal to 8. Once you write down 3 sides of this triangle, you should be more sensitive that 6 to 8 to 10, which means 3 to 4 to 5. This is a very common combination for right angle triangle. But don't forget that if you need to use this right angle triangle, you have to prove it by converse of Pythagoras theorem first. Here we just pretend that we don't notice yet. And then BD is equal to 15. We have to find out angle ABD. ABD. That means we interested in this surface, the closest surface towards the reader. And then if we draw the angle, we draw the triangle first. ABD. We know this is 86 degree. We know this is 10. We know this is 15. Our target is to get angle ABD. ABD. However, this one is not that straightforward, because the opposite angle of 10 should be angle ADB. So our first mission is to find out angle ADB first. Once we find out, then we can use angle sum of triangle. Now we start calculation. By using the sine formula, we may use sine this angle first about the fraction I. Sine angle ADB to 10 should equal to another pair, sine 86 degree to 15. That's why sine angle ADB is equal to 2 over 3 times of sine 86 degree. Angle ADB is equal to shift sine 2 over 3 sine 86 degree. Then you use your calculator. We get 41.68560132. Because it's not final answer, we write down more digit, and you should store it into your calculator. Alright, finally our target, angle ABD is our target. It's equal to 180 degree minus 86 degree minus the angle that we just found. We get 52.3 degree, correct to 3 significant figures. We already get 2 marks from it. Now we look at CD. CD is not on this plane. For line CD, you have 2 choices about the plane, and then we are going to make decision which plane we should use. The first choice is triangle ACD, this survey. The second choice is triangle BCD. And we should use triangle BCD instead of triangle ACD. It's because we have one side, 2 sides, and together with 1 angles. So it's very convenient for us to find out the last side. That's why we don't choose the blue plane, because the blue plane we only have 1 length here. To draw the plane, we have triangle BCD. From the top view, this one is 43 degree. This is 8, this is 15. Our target is CD. You may let it be X or Y. By this triangle, we have 1 side, 2 sides, 3 sides, and we have 1 angle. So we should use cosine formula so that we can put everything inside the formula. Y squared, because the this angle. square must be alone on one side. Is equal to a squared plus 15 squared minus 2 times a times 15 cosine 43 degree. Don't forget the cosine formula is c squared a plus b squared to ab angle c. If you're aiming 5 star, you should know how to prove this one. But anyway, so now all these are values. Then the only thing we have to do is just take square root on both sides. We use calculator. We get 10.65, that means 10.7 cm. Correct to 3 significant figures. Then we already get and don't forget to write down y here, that means CD. Or you directly write down CD squared here if you get used to it. And then in part B, someone claimed that the angle between line AB and the face BCD is angle ABC. They're asking about this line compared with this plane. The angle between them is that this angle. The key point of this question is just simply asking you, is AC vertical to the blue plane here? If AC is vertical, that means C can represent the projection of A. And then that means this can represent the angle between them. That means the key point is, we know this is right angle, but how about in any other direction? Is that also right angle? If it is, that means we confirm this angle is the angle between the line and the plane. But if this angle is not 90 degrees, which means that BC, this line, cannot represent the blue plane here because A projection is not project to C on this plane. And don't forget, usually part A and part B are related. In part B, we already know how long is CD. It's around 10.7 cm. If we can find out AD, then it's strong enough for us to prove is that right angle or not. How can we find AD? Of course, we look at the triangle ABD here. So we join once again with 86 degree ABD. We have 10, we have 15, so of course it's easy for us to find out what is AD. So our first mission is find out AD, and then we are trying to use Pythagoras theorem, converse of Pythagoras theorem, to prove that is that 90 degree or not. So the angle we have is 86, so 15 square is equal to 10 square plus AD square, and then minus 2 times 10 times AD cosine 86 degree. To handle this equation, you find that AD square exists at the same time AD exists. It is quadratic formula, a quadratic equation, so we are going to use quadratic formula. Make one side become 0. We tidy up like this, then we just simply use quadratic formula directly. We get AD is equal to 11.8996, or AD is equal to negative 10.5045 something. Of course, this is rejected. And then we are going to confirm is this right angle here. So we consider AC squared plus CD squared is equal to 149.475 something. And at the same time, AD squared is 141.6015 something, which is obviously not equal to AC squared plus CD squared. Therefore, this angle is not 90 degrees, which means that this angle is not the angle between the line and the plane. Therefore, angle ACD is not equal to 90 degrees. So angle ABC is not the angle. AB and plane BCD. Why I introduced this method is because this is more general. Sometimes it's because in part A we already find out this angle ABD. So we may use this result 52.3. By using cosine formula, we get AD squared directly. Then you don't need to handle the quadratic formula here, which is exactly the same result.